class, it's Miss Airline. We are going to talk today some more about our frequency distributions. We're going to get into looking at how to take these frequency distributions to where we have organized all of this information, and we are going to put them into graphs now. So we're going to focus on a couple of graphs in today's lesson. We're going to practice them. And a lot of what you're going to see in the practice is not only are we going to be creating these graphs from our frequency distribution tables, but we want to make sure that we know how to analyze these graphs and read them also when we are given these graphs. So over the course of the next couple of days before we quiz on this, we're going to be doing some practice in Delta Math, as well as some practice in the Math Excel website. And we are going to do some on a piece of paper, draw a graph. So let's go ahead and get started with lesson 4 on statistical graphs. This is a part of the slides from the other day where we started talking about frequency distributions. So that was like last week. So where we looked at and so I'm going to back up really quick for a moment. How do I take a group of data and organize it into classes? And so we did a couple of type of examples. We did this one basic one where we said, okay, our data doesn't have a huge range to where we need to like chunk the data together. But we can just say, well, let's look at the observed values. Let's look at the responses we got from this particular survey. We got from 0 to 9. And so each number was its own class, and we were able to then organize it based on saying, okay, well, how many of each value do we have? And so that's where we got this frequency side of our table that's telling us how many of each number we got. Then we spent some time with saying, well, what if I want to group my data together in classes? So each class is like this number to this number. And that's where we started creating our upper and lower class limits. We have to focus on the class width. And then we went through each class and we calculated our frequency. We took some more time also in yesterday's lesson to say, how do I take this grouped data, calculate a class width for it based on how many classes I want, and then start to organize it to find the midpoints of the class, and not just the frequency, but also things like the relative frequency, the cumulative frequency, as well as the cumulative relative frequency. So that's what we've kind of worked on the last couple of days. So now as I go back to this lesson, what we want to do now is we want to get into, well, now that I've created these frequency distribution tables, how can I now take that and graph it? How can I get a visual now so that I can start to analyze other patterns that's going on in my group of observed values? So the first type of graph that we want to talk about today is a histogram. You've been talking about histograms in mathematics for quite some time. These are just your basic bar graphs. They are different from a bar graph because typically we see a bar graph being used for categorical data. So that's a term, categorical data. I think I spelled that right. Let's just pretend I did. Categorical data is just, I'm grouping things based on some sort of quality that's not numerical. So we all remember those bar graphs from like elementary school to where it was like, what color shirt is everyone wearing? And then the horizontal part of your bar graph was the different colors. So someone had red and blue and green and white and so forth. And then your y-axis of your bar graph would be the frequency. So how many people had a red shirt on? And usually when we would create these bar graphs like that, though, what you'll notice is the bars are spaced out. Okay, and that's very typical for categorical data. A histogram now is your bar graph, but for numerical data. Instead of having words down here to represent your categories of your x-axis, can you see that? There you go. What we're looking at in a histogram now is I'm still looking at my horizontal and vertical axis, but now I'm going to use the number line quality of these axes to say, well, my bars should extend across the number line in such a fashion to where there's no space in between each graph. And so we're going to talk about how our frequency distribution table starts to set that up for us. Again, our horizontal axis is going to come from the observed values. So as we look at our data set, the classes that we're going to group this information into is going to be what we put on the horizontal x-axis. And then our frequencies will go on the vertical axis. We'll also see in some graphs that instead of using frequencies, we can also use relative frequency, we can use cumulative frequency, or we can even use cumulative relative frequency. And we basically just describe that in the name then, based on if I'm drawing a frequency histogram versus a relative frequency histogram. And these types of graphs, they're used all over the place. So let's look at how we are going to construct a histogram. Okay, we're going to construct this by really the main part, looking at our frequency distribution table and saying, let's use the class limits or the classes that we have to establish our number line on the x-axis. We aren't going to have to start the x-axis at 0 based on what numbers show up in our data set. But we're going to basically create the x-axis as the portion of the number line that we need that fits our data. Then we're going to have to create a vertical axis, our y-axis, to scale to fit our frequencies. We will need to start the vertical axis, though, at 0. We won't have to start the x-axis at 0, but we do need to start the frequencies at 0. And this goes back to what we read about in that lesson 2 with misuses of statistics. If we give a vertical axis that isn't starting at 0 and not scaled properly, what happens is then we can give a misleading graph. We can, though, however, put a break in our graph, the vertical axis, to accommodate for if I have large frequencies, and I'm not going to end up having like a really small one. And I'll show you how to do that at some point when we cross that bridge and need it. So let's kind of look at two types of histograms, okay? First, let's go back to the situation to where it was an observation to where we were looking at the number of children that different families have. And so the possibilities that are the possible results that we got from people were some had 0, some had 1 child, some had 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's over here. That's these observed values. And then we looked at, based on our list of data, the frequency that each of those responses showed up. So we had, for the number of children being 0, we had 8 couples that responded with that. 1 child, there was 11 children, 11 couples that said they had 1 child, and so forth. What we're going to do with our histogram is we are going to use these number of children, or the observed values, as our x values. Basically, these are the classes. And then we're going to use our frequency as the y-axis. And what we're going to do is we're going to start to analyze and look at how should I scale the horizontal and vertical axis. What you'll see here is that it is feasible to scale the horizontal axis from 0 to 9. Because if I look back at my frequency distribution table, my x values go from 0 to 9. So that's the part or the chunk of the x-axis that I want to deal with. For our frequency, or the y-axis, we want to scale it from 0 to 20. And that's because as I look at my frequencies, I see the highest one is 18. And so it's nice to scale up to either a number that's multiple to by 10 or by 5. And so we just said, let's just go to 20 in this case. And so now what we'll do is we are going to create the heights of the bars in our histogram based on the frequency. And so we end up with a picture like this. Notice we've got a lot of things labeled. First, we've got a title to our graph, the number of children per family. We also have our X and our Y axis labeled. Okay, so we've got the number of children versus the frequency of families. And then you'll notice that this was our ungrouped situation. So what we did was we just created the x-axis such that it scaled from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we created our bars so that those numbers were in the middle of the bar. Then we scaled the y-axis all the way up to 20. And notice there is a tick mark for every value between 0 and 20. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it is helpful that in this case, we did not label each tick mark. We just labeled every fifth one. That just makes your graph not look so crowded. And so now all we have to do is flip back to our table and say, well, the height of my bar over 0 should be 8. So over 0, this bar has a height of 8. Then the next bar has a height of 11. Then the next bar had a height of 18. Then we had another bar of 11, and then so forth. And notice how each of the bars is touching the next one beside it. Now, let's switch back to this example that we did in our video the other day, to where we created a more complex type of frequency distribution table. I can't remember what this example was about. Maybe it was about hot dogs or something. I don't know. Nope, it was about the number of minutes that it took people to read a newspaper. So it was about hot dogs. There we go. What we do to set up our histogram in this case is, again, we're going to start by saying, let me make my X and my Y axis. And we're going to do that by saying, let's look at our class limits and let's look at our frequency. And now this is where it's going to differ slightly though. We're going to take our class limits and we are going to turn them into what's called class boundaries. The class boundaries is what's going to allow our bars and our histogram to touch when I graph them. So look at our class limits for our first class. It goes 0 to 7. Then our next class goes from 8 to 15. Well, if I'm on a typical number line here, all right, and I've got 7 right here and then 8 right here, okay, when I go to make these bar graphs, the bar that's at 7 would end up having a space between it, and then I would start the bar that would start at 8. And we don't want this space right here to exist. So what we're going to do is we're going to create class boundaries by pulling out this edge and pulling back that edge so that they meet in the middle of that gap. So what would the middle of this gap be in between 7 and 8? Well, it would be 7.5. What we're going to do is we're going to take this whole idea of the halfway mark in between each of our classes, and we're going to stretch out the class limits to create class boundaries that are going to meet up and start at the same number or end at the same number. So let's kind of look at how we're going to do that. So my first class, lower limits was 0 to 7. So I'm going to now create a lower boundary and an upper boundary. And I'm going to create these from our class limits. So our first set of class limits was 0 to 7. Well, we've already talked about the first class upper boundary. We're going to stretch that out to 7.5. And then on our next class, where we have 8 to 15, we're going to back up the 8 to 7.5. Now, the 15, we're going to stretch that out to 15.5. And then when I move to my third class, I'm going to back the 16 back to 15.5. So notice now what's happening is I've got this kind of slanted similarity of numbers. So my 7.5 here matches with the 7.5 there. My 15.5 here matches with the 15.5 here. So what we'll see is this number that I'm going to put here is going to match with this number that I put here. And let's look at what that number is going to be. My next class, we're still in the class from 16 to 23. So we're going to take that 23 and we're going to stretch it out a half. So that's going to move to 23.5. So now this down here is going to be 23.5. Basically, I'm taking the 24 in my next class. So we've moved to here now. I'm taking that 24 and I'm backing it up to 23.5. Now the 31 is going to get stretched out to 31.5. Then the next class is going to start at 31.5, but then the upper limit is going to stretch out to 39.5. And now what we're going to do is we're going to extend one more time at the very end and at the very beginning. So I'm going to go back to the very beginning, which is the 0. And I'm going to stretch that back a half also, which is going to take me into the negative side of things, but that's okay. Now, let's go back to the very end now at 39.5. Let's go ahead and stretch this to where this is going to be 39.5. And we're going to stretch it up to, let's just leave that like that. So now this is going to be what I'm going to use as my number line for my histogram. So I'm going to create me an x-axis. Again, our x-axis is representing the number of minutes reading the newspaper. Okay, and then I'm going to look at the frequencies to see how far I need to scale up. So my frequencies go 8, 8, 3, 3, 3. So maybe I can go up to 10. So I think I got room. So we can do a 2, 4, 6, 8, 10. Bam, that'll work. 2, 4, 6, 8, 10. I know halfway in between there is going to be my odd values. Okay. And now my class boundaries, I'm going to scale these slightly differently. I know my class width is 8. And so I don't necessarily need to utilize 8 spaces in between each tick mark now. But I'm going to start with the negative half here. And then let's go 1, 2, 3, 4. And we can put 7.5 there. And then we can go 1, 2, 3, 4. And I can put my 15.5 there. And then I can do a 1, 2, 3, 4. And I can put my 23.5 there. And then 1, 2, 3, 4. And I can put the 31.5 next. 1, 2, 3, 4. And here we can put the 39.5. So I've got a little bit of erasing to do so that I can extend out this x-axis a little bit more. So let's erase that also and move that over. There we go. And so now what I can say is my first bar is going to go from the 0 to the 7.5. are the negative half to the 7.5, and it's going to have a height of 8. So my first bar is going to be up here. Okay. Oh, let me label my y-axis. So this is frequency. Okay, my next bar is going to go from the 7.5 to the 15.5, and it also has a height of 8. So because it's starting at 7.5, we're going to see that those two bars being back to back. My next class has a height of 3, so that's 2, 3 will be right here in the middle, and I'm going to go all the way to the 23.5. And then the same thing with my next class, and the same thing with my final class. And so that would be a picture of my histogram. Looks kind of uniform, kind of flat across. It's not doing one of these kind of increasing and then decreasing, which is fine. Another type of graph that we can create is a frequency polygon. In our frequency polygon, what we do is very similar to our histogram, only instead of creating bars, we are going to use line graphs. We're still going to have the scales similar to what we had on the histogram. We're going to have our horizontal scale be the observed values, and our vertical scale will once again be frequency, or we could use it as relative frequency. What you're going to do here, though, is instead of making the height of the bar for your histogram be the frequency, we're going to place a dot at the corresponding frequency above each of the observed values. So this is going to look more like plotting points or taking these particular values in our table and creating them into ordered pairs. So this is going to look more like plotting the point 0, 8. And then this one will be like 1, 11. And then that one will be 2, 18. And so forth. We're basically going to turn them into ordered pairs, and then we are going to connect them with a line graph. What you will see also is that we're going to tend to use the midpoints of our classes for our frequency polygon. So let's look back at this example here. I thought this was a good example to deal with because we've already done the table for it. So what we're going to do is we're going to say, let's now put the midpoint on our graph. So halfway in between our negative 0.5 and our 7.5 would be the 3.5. Halfway between the 7.5 and the 15.5 would be the 11.5. So we've already done all of the work up here when we calculated midpoints. So I'm just going off of the same values here. So then the midpoint of this next class between 15.5 and 23.5 will be our 19.5. Halfway between here will be our 27.5. And then halfway between here will be our 35.5. What our instructions will say do now for a frequency polygon is it's going to say we're going to add an additional midpoint. We're going to add one at the beginning, and we're going to add one at the end. And this is where our class width is going to come back into play. So remember our class width was 8. So what I'm going to do is I'm going to take the first midpoint, which was 3.5, and we're going to subtract that class width from it. So 3.5 minus 8 gives us negative 4.5. So my next midpoint then would be 1, 2, 3, 4, would be right here at negative 4.5. I'm going to start with an ordered pair of 0 as the frequency right there. Then on the other end, past the 39.5, I can take the highest midpoint and add my class width to it. And I'm going to get my final midpoint of 43.5. Again, this is going to end up being a point with 0 as its frequency. Now, we're going to use the midpoint as my x value, and we're going to use the frequency as my y value. So my first ordered pair is going to be 3.5, 8. Notice how that ends up being just at the very top of my bar graph. Same thing with my next midpoint. The midpoint 4.5 is going to have a y coordinate of 8 also. So I'm going to put a point here. My next frequency is 0. So at the midpoint of 19.5, we're going to have a frequency of 0 or a y coordinate of 0. So that's going to be a point there. We're going to have a point here. We're going to have a point there. And that's all of my points. Now I'm going to connect them all with segments. And so basically what we're starting to do is we're starting to fit a curve over our bar graph. So we're going to kind of walk into this process of creating these graphs. We're definitely going to work some more in these for the next couple of days. So the first thing that I want you to do is I want you to practice some more with connecting the frequency distribution table to our histogram using Delta Math. So head over to Delta Math and get started with this particular assignment. Bye.